Now, let's talk about Power over Ethernet or PoE. PoE allows a single Ethernet cable to carry both data and electrical power to a device. So instead of running a separate power cable, you can power things like Wi-Fi access points, security cameras, or voice over IP phones directly through the network cable. Here I have my UniFi Lite PoE switch with first 8 ports as PoE plus or standard IEEE 802.3AT. We'll go over the standards a little bit later in this video. You can see I have got my UniFi 6 Lite Wi-Fi access points connected to port 7 PoE port and my Cloud Key Gen 1 connected to port 3 of the switch. Both of these devices are powered over a single Ethernet cable, as you can see here, and they are getting power and data through the same cable. This makes installs much cleaner at your commercial or residential spaces, especially when devices are mounted on ceiling or walls, such as these Wi-Fi access points. On the switch, you'll notice some ports are labeled PoE and others are just non-PoE. For instance, if I plug my UniFi Cloud Key to a non-PoE port, let's say port 11, you would notice no power getting delivered, in which case I would have to connect an external power to power this on, which means more number of cables and less tighter the network would be. These PoE Plus ports deliver more power than regular PoE. For example, a UniFi 6 Lite Wi-Fi access points can run fine on a PoE port, but more power-hungry devices like PTZ cameras or high-end voice-over IP phones or some advanced Wi-Fi 6 access points might need PoE+. On the screen here from the Ubiquiti website, I'm going to show you a demo for a network switch. Let's go switching. A good example would be a Ubiquiti Pro 24 PoE switch right over here. This is a managed switch that supports different PoE standards. If I click on technical and scroll down, uh, what's going on? Okay, technical, let's scroll down to the PoE section. And as you can see, this includes PoE Plus, which are 16 ports, and PoE Plus Plus, which are 8 ports, and the total power consumption is 450 watts, including the PoE output. So when you're looking at switches like this, the key is to check which PoE standard they support and how much total PoE budget is available, so you know if it can handle all your connected devices for your needs without running out of power. There are a few different PoE standards. The original one was PoE, also known as IEEE 802.3AF, which could only deliver up to 15 watts per port. Then came PoE Plus or IEEE 802.3AT, which was a switch that we demonstrated in this video earlier on, which increased it to 30 watts per port, which, which is good for devices that needs a bit more power, like high performance Wi-Fi access points. Next was PoE++, which this switch has 8 ports off. It's also known as IEEE 802.3BT Type 3. This can deliver up to around 60 watts per port, which is enough for devices like PTZ security cameras or more demanding network gear. And finally, there's also PoE++ or IEEE 802.3BT Type 4, which can go all the way up to 90 to 100 watts per port. That's used for really high power devices like digital signage, LED lighting, or even some mini servers. One last point to cover is your Ethernet cable matters too. Cat5e can technically handle PoE++ over short distances, but for anything high power and over 50 meters, you'll want at least Cat 6. If you're building new, go with Cat 6a. It supports higher bandwidth, higher power delivery, and is better shielded against interference. This is especially important for devices that might draw 60 to 90 watts. Using lower grade cables can lead to voltage drop, excess heat, and reduced device performance. Hope you find this video helpful. I have got more unified tips and walkthroughs coming up, so please follow for more. Thanks.